Alright, good day everyone. The question for today's class is how good are you with guns? Okay, how good are you with guns? So we want to see how we can use physics to explain how a gun works. Like I said, physics is life, alright? And one of the beauty of physics is the ability to express real life situations using equations. Now, follow me. How good are you with guns? Now, we have a gun, we have a diagram on the board. We have a gun, we have a bullet. Now, we have the gun principle. Now, what is a gun principle? All right. Now, there are two basic principles that the gun works on or the gun operates on. Now, the first is called Newton's third law. Third law of motion. Alright? And the second one is principle of conservation of momentum. Now, let's look at the principle first of all, the principle of conservation of momentum. Now, what is momentum, first of all? You hear people saying, I've gained momentum, right? So, momentum is simply, in physics, momentum is simply the product of the mass of a body and its velocity. Capital N, momentum, the product of mass of the body and the velocity of that body. Now, so we have mass measured in kilogram, velocity measured in meter per second, which makes the SI unit for momentum as kilogram meters per second. Now, quickly to our question, the gun, all right? Now, how does a gun work? Simple. We have two things involved. We have the gun, all right, and we have the bullet. So we have the gun and we have the bullet. Now, the principle of conservation of momentum states that if two bodies, all right, in a system collide, all right, the total momentum before collision is equal to the total momentum after collision, provided those bodies are in a closed system. What is a closed system? A closed system is a system in which no external forces or external agents act. For instance, a man and his wife, they are fighting at home. They shut the doors, shut the windows. Nobody comes to separate the fight. Okay, that's a closed system. Practical, all right? It's a closed system. Nobody, your neighbors coming out, banging the door. Please open the door. Help. You understand? So nobody comes in. Nothing goes out. That's a closed system. No external interference. All right. So that's the principle of conservation of momentum, or principle of conservation of linear momentum. Now, and the formula is given as this. The formula is given depending on the direction of the two bodies. Now we have the formula as M1 U1 plus M2 U2 equals to M1 plus M2, right, V. Now, what do we have here? We have that M1 is the mass of the first body. So let's take the mass of the gun, which is the first body, as M1. Okay? The velocity of the body, since it's represented as V here, let's just use it as U1. Okay? So let's use it as U1. So let's use our V to be also equals to U1. Then for the bullet, mass of the bullet is M2, and this is the speed of the bullet, U2. So we have our M1 U1, M2 U2. Quickly, how do we solve this question? Now, how do we solve this question? Now, let's go. From here, M1 is what? 10 kilograms. U1, before the bullet was shot out of the gun, the bullet was inside the gun, meaning the bullet and the gun, they are at rest. So I put the bullet in the gun and hold it, okay, waiting for an intruder before I pull the trigger. So The initial velocity of the gun is 0 because it is at rest. I've told us that when the body is at rest, it simply means that nothing is happening, no motion, no movement, 0. Mass of M2, mass of the bullet, 20 grams, is in grams. So we have to convert this to kilogram. And to convert grams to kilogram, we divide by 1000. That will give us 0.02 kilograms. Can use your calculator to confirm that, right? So that's 0.02. And the initial velocity of the bullet is still inside the gun. We've not pulled the trigger yet, so that's 0. Equals to M1 plus M2, that is 10, plus 0.02. Okay? And then our V, okay? The final velocity. Now, but because after collision, the bullet and the gun did not stick together, they did not coalesce. This formula is used when after collision, for instance, a car colliding with another car. Then after they collided, they now move together with a common velocity. But in this case, we pull the trigger, the bullet leaves the gun. The gun the gun is on its own. The bullet has left. Okay, so the gun is on its own, the bullet has left. So in this case, this formula we need to modify it a little. That means after we pull the trigger, the gun will have its own velocity and the bullet will have its own velocity. That is why you see that it's somehow different here. You see V, okay, and you saw the velocity of the bullet. So after you pull the trigger, this formula now modifies. You can modify this formula, okay? Let's have it here. We can modify this formula as M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. The gun now possesses its own velocity. The bullet possesses its own velocity. So let's go back and now make this. Instead of V, you have V1, and this now becomes what? V2. U represents our initial velocity, they are at rest, so 0 meters per second for both of them. And V represents the final velocity. Alright, now come on. So that means our formula we now have from here. We'll have, this is 0 already. So we'll have from here, we have 10 times 0, 0 plus 0 equals, we'll now modify this place. Since they will not move with the common velocity, we'll now have 10 V1 plus 0.02 V2. So I've modified this part so that they can have their respective final velocities. Now if we come to this part to finish up our question, if we come to this part to finish up, what do we now have? We have 10 V1. What's our V1? We don't know. We're looking for the velocity of the gun. The velocity of the gun. So that's 10 V1 plus 0.02. What's V2? Final velocity of the bullet. That's 400 meters per second. So we have equals to 0. Okay? Everything is equal to 0 from this side. So we have 10 V1 plus 0.02 times 400. 2 zeros, that's 8. And that's 0. So if we collect like terms, let's come over to this side. If we collect like terms, we are going to have 10 V1 equals to 0 minus 8. And 10 V1 is minus 8. Divide both sides by 10. What do we have? V1 is minus 0.8 meters per second. And that is the velocity of the bullet. Minus 8 minus 0.8 meters per second. So V1 is minus 0.8 meters per second. That is the velocity of the gun. Now, what do we call this velocity in physics? We call it, there's a name for it, and it's called the recoil velocity. We call it recoil velocity. Now, before we end the class, what do you observe? See the arrow, see where the bullet is facing. See where this arrow is facing. Okay? And another thing you should ask, why are you sure? Are you not sure that we have a negative answer for velocity? Negative answer. Why is it negative? That shows to validate the fact that Newton's third law of motion is correct, which states that for every action, there is an equal and what? Opposite reaction. So, The negative is showing what? The opposite reaction from the gun. So when you pull the trigger, there is a force. There's a velocity that pushes you backward. That velocity is called recoil velocity, reverse velocity. So when the bullet goes forward, the force pushes your hand and the gun backward. That is a validation of Newton's third law of motion. So that is why we have this negative sign. So if you can summarize your answers, V1 is 0.8 meter per second. So you are still correct without putting the negative sign. Negative sign is just showing us that Newton's third law is being obeyed. So the velocity acts the backward direction while the bullet acts in the forward direction. So I believe I've been able to explain the analysis and the principle, the formula behind the working principle of a gun. Thank you very much. Please like and share this video to as many people and many students that are struggling with physics, as it could be of great benefit to them. See you in the next class. God bless you.